Okay, so we've got this function. The graph has that, max points. Write down f at 1. Okay, that's 3 and 3, both of those. Okay, so show that the period's 4. So from max to max, well, it's just 5 minus 1 is 4. Not sure what they want there. So now the point is a minimum. Show that A is 2 and find the value of B. So A is the amplitude, so you've got max minus min over 2, which is 2. Find the value of B, so we've got 3 plus negative 1 over 2, which is 1. D, solve the equation f at x equals 2. All right. So we've got 2 sine pi over 2x plus 1 and yeah, I was just checking to make sure because this is a sine function. It's starting by going up. So that's all right. It's a positive 2. So we want this to be equal to 2. So that's 1. When you subtract 1, it's 1 over 2. So 1 over 2 sine pi over 2x. And we want from 0 to 5. So we need to multiply by pi over 2. So sine is 1/2 at pi over 6. So, and we're going from 0 all the way around to 2.5 pi. So it's, and it's positive. So we have here, here. So pi over 2x equals pi over 6, 5 pi over 6, and then again to 13 pi over 6. And then we stop here. So it's here, here, and then back around to there. All right, so now we're dividing by pi over 2 or multiplying by 2 over pi. So this is going to be 1/3. Then we're going to have 5/3, and then we're going to have 13/3. Okay, so now for E, consider the equation f at x equals k from 0 to 5. Write down the values of k for which it has one solution. So that's just down here. So for I, it's just k equals -1. Exactly 3 solutions. So this is, so 1, 2, 3. So below that, so for double I, it's from 1 to, so here is 3, here is 3, up until, so equal to 1, and up until 3, but not 3, because at 3, it's got 2 solutions. But also below 1, so below 1, it's got 2 down to -1. So 1 to -1, because at -1, it's got 1 solution. No solutions, it's going to be greater than 3 or less than -1. All right, so 35, we've got this function, calculate the depth of the water when t is 2. So that's sine 1. Okay, so we have to use calculator for this. So if you just go to, you can either put this into the graphing calculator, or you can just do it on the regular calculator screen. Whoops. So when t is 2, it's 13.4 meters, 21 hours. So number of hours after midnight, that's going to be, oh yeah, we just substitute in 21. 21 over 2. So this is 6.48. All right, B, write down the max depth of the water. That's 14. Calculate the value of T when the water is first at its maximum depth. So we want, it's at 3, it looks like. Okay. Then I'm thinking calculate the value of T. So maybe we should graph this and then find that maximum. Yeah, so it's actually 3.14, so it's pi. All right, C. However, gates are closed when the depth of water is less than 7 meters. The alarm rings when the gates are open or closed. How many times does the alarm sound during the day? So we need less than 7 meters. So on the graphing calculator, I'm going to put in 7 and find those intersections. And so here, so if we put in 7, this here is 7.98. And then here's at 10.9. And then here is 20.5, this one. And then it's going to ring 4 times. I'm just getting those actual values. 23.4. So 4 times, this is the time, the value of T when it first alarms, 7.98. Use the graph to find the length of time during the day when the harbor gates are closed. Give your answer. So we're going to do from 10.9 to 7.98 and 23.4 to 20.5. Those are the times when the between which the gates are closed. All right, so this one is 2.92 hours the gates are closed, and this one is 2.9. So when we add those together, that's 5.82. So 6 hours to the nearest hour. All right, 36, we've got this same harbor depth. In the following graph, that's a min, that's a max. Find the value of Q, find the value of P. So P is max plus min over 2. Q is max minus min over 2. So this is equal to 11.4, and this is 3.2. Find the first time in the 24-hour period when the depth of the water is 10 meters. So I'm going to graph this, and then I'm going to put in the horizontal line 10, and then I'm going to find that intersection. So that's happening at 3.86. Use symmetry of the graph to find the next time when the depth is 10 meters. So if this is 6, this is 3.86, we know that that's a distance of 2.14. So we need to do 6 plus 2.14 symmetrically, which is 8.14. Okay, so then, hence find the time intervals in the 24-hour period during which the water is less than 10 meters deep. So it's in between 3.86 and 8.14. Then, if this is at 18, well, what's the period here? 2 pi over 6, which is 12. So if we add 12 to both these, that's 15.86 to 20.86. All right, the graph, more water. Use the graph to write down an estimate of the value of t when the depth of the water is a min 7, max 1, and 12. The depth of the water is when the depth of the water is increasing most rapidly. So I think it's happening like here, like these inflection points, which we'll get into later. So it's increasing, that would be at 10, because at 4 it's decreasing. All right, it can be modeled by that thing. So show A is 8. So it looks like the min here is at 2. So I suppose we can do the principal axis minus the min. And then write down the value of C. So that's 10. Find the value of B. So it's going, so this is a cosine function. So this max used to be here. It's been moved over by 1. Oh, okay, never mind. B. So this is talking about the period. Well, okay, so from 1 to 7 is half. So that's 6. So 12 is a full. So we're going to have 2 pi over 12, so pi over 6. A sailor knows that he can't sail past P when the depth of the water is less than 12. Calculate the values of T between which he cannot sail past P. So 12 is here. So we need to know this value and this value. And that's when he can't sail past P. So we're going to put it in the graphing calculator, find the intersections. So that's happening at 4. No, 12. Sorry. I did 10. Okay, so that's happening at 3.52 to 10.5. Okay, we've got this thing, sketch the graph, right time, all that stuff. Okay, so on the graph, we've got to get these endpoint values. So graph trace, we need -2 pi. So at -2 pi, it's at 4. All right, and then at 2 pi, yeah, something like that. It's going to be also 4. It's not really, maybe here. Okay, so those are the endpoints. We need the x-intercept, so zeros. So we've got -4.07. Then we've got -0.927. Then we have 2.21. And lastly, we have 5.36. And we need y-intercept. So 0.4. That's pretty clear. Now we just need the maxes and the mins. So first min is at -2.49. So basically right there in the middle of that and -5. So like here. So -2.50, -5. And then the other one is 3.79. Oops. 3.79 -5. It's positive. And we have some maxes, of course. We've got -5.64. positive 5 here. We have 0.64. And that's that. So then something like this. Okay, ridiculous. Write down the amplitude. So it goes from -5 to 5. So amplitude's 5. And double I, the period. So in between, yeah, it's not helping actually. So between a max, we've got 0.644 minus a -5.64. That's one period. Okay, so 5.64. So 6.284. That's probably 2 pi, isn't it? Yeah. Okay. The x-intercept between -pi/2 and 0, so it's -0.927. All right, hence write in the form that. Okay. So 5 is the thing. So we have R has to be that. So they made us write that down because that's going to be here. So 0.927 is that shift, and the Q is the period. So that's just going to be 1 because 2 pi over 2 pi is 1. So it should be that. What I would do, since it's with graphing calculator, I would put this in and make sure it lines up on top of the graph that we've got, which mine does. So write down the two values of k for which the equation that has exactly 2 solutions. So definitely k equals 5. And k equals -5, and everything in between is not, it's having more than one solution. Because up here it just has 1, because it won't have here, and down here has, 2 solutions. All right, 39, spring, finally, not water. Find the length of the spring after 1 second. This is with graphing calculator, so if we go and do 33 plus 5 cosine 720 degrees, change it, and times 1, so that's 38. Find the minimum length of the spring. So we've got 33 is the principal axis. It goes down 5, so that's going to be 28. Find the first time at which length is 33. So we've got 33 equals 33 plus 5 cosine 720t. So that's 0. So when you subtract 33, it's 0. Divide by 5 is 0. And then cosine 0 at 90 degrees. And then plus 180 degrees. Okay, so here and here. So that's 720t. So if we divide by 720, that's 1/8 plus 1/4k. That's t, so the first time should be at 1/8 seconds. What's the period of the motion? So we just do 360 over 720, which is 1/2. All right, number 40. A Ferris wheel with center O and radius 15 is represented in the diagram. A is at ground level. The next seat is B and pi over 6. Find the length of the arc AB. Okay, so for A, length of the arc is radius times theta, so 15 pi over 6. That is how long the arc is. For B, find the area of the sector. That's 1/2 r squared theta. So 225 pi over 12. C, the wheel turns clockwise through an angle of 2 pi over 3. Find the height of A above the ground. Okay. So 2 pi over 3 is going to be like, like here. Let's see. All right, so we want this. We know that that's 15 because that's a radius. This is, what is that? Pi over, so that's 2 pi over 3. So this is pi over 6, right? Because it's basically 2 pi over 3 minus pi over 2, right? So, yeah. All right. So now this is 15. We want this length. So this is opposite over hypotenuse. So we need sine pi over 6 equals x over 15. 1/2 times 15. So that is 7.5 plus 15, so 22.5 meters above the ground. All right. D, the height h of the seat A above the ground after t minutes can be modeled by that. Find the values of A and C. All right, so we have, this is 15, this is 15. So the max is 30 plus the min is 0 over 2. So C is 15 and A is going to be 30 minus 0 over 2, so also 15. Okay, so then find the time for a complete turn of the wheel. So we've got 2 pi over 2, which is pi. So I think that 3.14 minutes to go all the way around. So from min to a min. All right, so the height h meters of the seat C, so that was A, this is C, above the ground can be modeled by that function. Find the height of the seat when t is pi over 4, so we've got pi over 2 plus pi over 4, which is 3 pi over 4. Cosine at 3 pi over 4 is negative root 2 over 2. So that's going to be the height if we do that in a calculator. 15 minus 15 root 2 over 2. So negative. So this is 25.6 meters. Find the initial height of C, so that's just 0. So that's going to be the 4.39. when we do 15 minus 15 times root 2 over 2. Find the time at which C first reaches its highest point. So the highest point is going to be 30 because you've got the principal axis and you go up 15 and down 15. So we want to know when it's 30. And this is okay, so subtract 15, that's 15, divide by negative 15, that's negative 1. Cosine's negative 1 at pi plus 2 pi k. So this is equal to 2t plus pi over 4. So if we subtract pi over 4, that's 3 pi over 4 plus 2 pi k, and then we divide by 2. So that is at 3 pi over 8. Yeah, 3 pi over 8.